Okay, here we've got a question which is about a probability density function. So we're in the world of continuous random variables. There are always two continuous random variable questions on the paper. One will be the rectangular distribution, the other will be the more general type. You might want to identify those two questions and compare them so you know which type you're dealing with here. In this one we've got to sketch the graph of f, so we've got two really pretty similar, simple functions of t, but for this one here, if you multiply that out you'll get t squared. You should know what kind of graph that is, and you might need to do a little bit of core 1 kind of thinking about that style of graph in order to get full marks for its shape. But always work out the end points, so work out the values of the functions at 0, 3 and 3 and 6. Make sure you use those points and think carefully about the shape of the curved bit of graph. Write down the probability of t equaling a specific value from a continuous random variable. That's a knee-jerk reaction. You should know the answer to that instantly. Then we've got to find the probability that a randomly selected supporter has to queue for at least 3 hours. So supporters queuing times are t hours, so this is the probability that t is at least 3. Okay, and therefore we have to, on our sketch, show a particular probability, in other words a particular area under the graph, and use integration or a simpler method for area to calculate the probability of being at least 3. There's more than one way to tackle that depending on which side of the 3 boundary you decide to calculate the area. Part D is showing that the median queuing time is 2.5 hours. Now the median is the value with the property that the probability of being less than it is 0.5 and the probability of being greater is also 0.5. So once again on a copy of the sketch, find an area that needs to equal, shade an area that needs to equal 0.5. Your answer to C will help you decide whether the median is in the range 0 to 3 or 3 to 6. So you can then set up an area, probably an integral, which needs to have 0.5 as the answer. One of the limits will be m, your median, and you'll be able to work through to find an equation for m which you solve, and you know the answer you're looking for is 2.5 hours. Then we've got a re-entry point here. Because we know the median is 2.5 hours, we need to calculate the probability that t is greater than the median or less than the mean. Now, in fact, you don't even need to know what the median is for that, because in your distribution we want the probability of being between the median and the mean, and this probability here will be all the area up to and including the mean value minus all the area up to and including the median. And the area up to and including the median you know is a half. So really what you need to know is the probability of being being less than or equal to the mean, or if you prefer, greater than or equal to the mean. But in order to get started on that, of course, you need to have a knowledge of what the mean is. We haven't worked that out yet, so you need to calculate the mean using the formula on page 11 of your blue formula book. It's two integrals that you need to set up, including your expression for f of t, but based on that formula on page 11. So you get a mean value, and then either integrate to find the area less than the mean or greater than the mean, depending on which is more convenient. And when you know the probability of being less than or equal to the mean, you can then use the fact the probability of being less than the median is a half to work out the shaded area, which is the probability that t is between the two. Hope that helps.